Okay, I'm a little bit early and I'm very aware of that. And I know that I'll have some folks join me. So you'll just be able to double back once I save this and record it. And so I'm going to go over here to our course. I'm over here in Canvas. And I'll find Management Science, Spring 2019, and here we go. As again, I said, I know I'm a little bit early. I'm about 8 or 9 minutes early. Okay, now I'm seeing just myself. Well, I have some people join. Anyway, I'm going to hang on a few more minutes here, and I'm sure we'll have some people, some folks join me, and we're going to work on the outliers case today. And just so that everybody knows, let's just go over quickly. Anderson, that test is due on the 12th, which is Friday at 5 o'clock. Then the outliers, it's the case we're working on today. This is the support center file that's over in the Foreman text. And then the single file Burger Dome, I covered that in the supplemental presentation that I did. And I told everybody, I told all of you, I spent Monday going through outliers, going through the Foreman text, okay? And then I said, I'll do a supplemental that covers single arbitrary. And then we'll focus again on the outliers case. And we'll go through the spreadsheet and we'll talk about that. Okay, so I'm a little bit early here, and I understand that. Okay, I'm seeing it's about 5 or 6 minutes early, so I'm going to go ahead and launch into this. Just as I was saying, we're going to have, you have an exam that's due on Friday at 5 o'clock. You've got the outliers file. That's the file from the Foreman text. It's called Support Center. And that is from Chapter 9. And then the Burger Dome case, that's the single file. That's over in Chapter 11 in the Anderson text and from those student files. And I did a supplemental presentation yesterday, and I posted it just to cover that. Got somebody at the door here, so I'll grab them here. Thank you so much. Appreciate it. All righty. All right. Thank you very, very much. All right, appreciate it. You have a good one now. Sure. Thank you. Okay, and I'll continue on here. That's module, and of course we're in module 10. Now, I have some resources here, and I didn't take any time to talk about them, but I'm going to do this real quickly. First of all, when we do the outliers case, we will be computing a z-score. And this calculator will give you the probability that you would get a certain z-score. Okay? So that's one of the ways to take a z-score and put it into context. And then I have, again, I mentioned to you an ROI on analytics. What kind of return on investment do we get when we use them? And then I have a couple of resources, as I mentioned the other day, on customer satisfaction and wait time. All right? So we've got that done. And now we'll be ready. Now, what I'm concerned about is I'm not seeing people starting to pop in, and we're getting near 11 o'clock. And I'm concerned because I think some of you may have the mistaken impression that the supplemental video that I posted yesterday did it for the week, and it doesn't. It's a supplemental video. This also, remember, as I told you before, on Monday, I was going to go through the Foreman textbook and talk about the case and what we were doing, okay? Then the next piece was this. I was going to go ahead and do the Burger Dome case out of the Anderson textbook and post it, all right? And then I was going to go ahead and give everybody there on today, go over the outliers. Now, I'm a little concerned, so let me go up here, and I'm pretty sure I posted a link to this. Yeah, here's the link to the invitation. Okay. April 10th, 11 a.m. There it is. So you have the invitation. And apparently I haven't had some folks zoom in yet. So this is strange. All right. And I'll go over here and check my emails separately and see if I'm getting some emails from people, if there's some kind of technical glitch or difficulty that everybody's having. Oh, let me go over there. And I'll look, first of all, I'm looking at the announcements. I hope I didn't mess us all up by not adding the link, but I'm sure that I did. This is Virtual Wednesday. There's the invitation. Okay. So that's the invitation. It's there. And let me look at there's the ID number. Check to see if we have any issues. Now we go back over here and check at Zoom for just a second. And see if you have the right, yep, 771-491-883. So you're good there. So far. Okay, and let me check my email. This is really odd that I don't have anybody here, so I'm not getting any reports from anybody that they're having trouble. And well, that's good. I think I'm going to have, we're going to have a powwow on Monday and have a discussion on this, because certainly this is not good. And I'm hoping maybe there's a chapel or something maybe that's it, a spirit chapel or something of that sort that's holding people from getting here. Now, okay. Well, this is a little bit disturbing, because we are having class today, and I suppose it's I guess if it's a joke, it's on all of you, because you're going to miss. I guess you can watch the video. Okay, so I'm going to go ahead and roll here for just a minute. Okay. Well, I'm thinking probably people got mixed up and thought because I did the supplemental that that was it for the week, but it's not. So I'm going to go ahead and go through this on the outliers. And I hope you listen to this, because I'll tell you where I'm at this point. I'm starting to get a bit discouraged to think that maybe this format is not going to work, and we're just going to have to go all the way back to ground-based. Folks, you know, we had a meeting scheduled today. We had a class. I'm not seeing anybody, and I'm not certain why I'm not seeing anybody in here. Maybe it's enrollment or something that's going on. I don't have a clue. And we'll go, I'm just going to go ahead and go forward with this, because I didn't see anything in the university announcements that said, you know, we're going to have big enrollment things. So maybe people are doing that. Anyway. Glad to see you here, Alejandro. Am I really, really later? you're the only person who's joined so far, so I'm going to go ahead, and you can see some of the stuff at the start of the video. I'm thinking maybe Chapel got out or who knows what. But anyway, you can scroll back to the start of the video after I've posted it, and we'll go from there. Glad to have you aboard. Okay, now, as I had mentioned, and I'll just go ahead and run through this again for you, Alejandro, and anybody else who joins, you can see on Monday I took the outliers case, and this is out of the Foreman textbook, The Data Smart, and we did the Chapter 9, the case on outliers. And I covered it, and I made it, and I went over through the text, showing you the screenshots, his comments, etc., just talking about the case and how it was put together. Now, there's a second video that I uploaded for everybody, and that one that second video was a supplemental video. I covered this case, the single or the Burger Dome, that's due on Friday, and that's from the Anderson text, the big textbook from chapter 11 there. And what we look at is a single server exponential arrival model. And as I mentioned, I give you a task, a couple of scenarios. And as I mentioned, the case is shown on page 515, and everybody will need to review pages 511 through 16. Now, I have a key that's in the next module, okay? And I also had a file that I worked on yesterday and showed everybody, and I don't think I uploaded it, but I may, but you still have a key. So that's the case out of the Anderson textbook. Well, let's go ahead and take a look at the Data Smart case. And again, this is from chapter 9, and we're looking at outliers. Now, let me take a minute, and we'll pop the file up, okay? And this is the support center file, and we saw screenshots of it on Monday, as I walked through the text and how this thing is put together. And again, just like we do in management science, we always use a model that works. And what we're going to do here is we're going to create a graph, and then we're going to use Euclidean distance just like we did in the cluster analysis. But this time we're going to flip it on its head and say I'm going to look for distances away from people, outliers, those who are outside the cluster or outside of what we would think would be the norm. And so you'll want to have your textbook open, and you really should have it. And then I also have a couple of files that we're going to talk about. Now, I'm going to start, of course, we've got the employee ID, the average day, tickets a day, customer ratings. We talked about that. And so we have these measures that they keep for everybody, okay? And this is over in the support personnel, and they talk about this. And now we just have each data for each of these employees. Now, what we're going to do, first of all, is we're going to summarize the data, okay? And that's a pretty standard practice. And you'll want to look at, it might even, the way I think to best understand this case would be to see the video today, okay? And let's see who also joined us. Glad to see you here, Caitlin. Thanks a lot. And the best way to understand this case, the outliers, is to see this video, I think, and then have the textbook, and then you'll see some notes there that I loaded. One is called Support Personnel Part 1, and then Support Personnel Part 2. Because what I do is I go and I take it. It's in my handwriting. I scroll some notes that will help you see what's going on. Okay, so we're starting here with the personnel. Now, one other thing, folks, I will probably go over 50 minutes. So if I run to a point where you've got to head to class or go head on to lunch, whatever, feel free to do that, because you can always come back to the video and pick up where you left off. Okay, that's the nice thing about this, is if you have to come in early or you have to leave early, the video's there. You can scroll forward, backward, and all that stuff. Okay, so we've got these data for these folks, and the first thing we're going to do is we're going to go down to row 402. And here we're going to do it. And here we start row 402, and we have the mean. In other words, the average for this person on the number of on the number of tickets that they do a day. So we know that with all these different employees, okay, remember there are 400 of them. Pardon me, yeah, 400, that we've got an average of 150 tickets. It's a call center. Now, we have an average rating for each employee, okay? And then we also compute the standard deviation. And I want to talk about this for just a minute. It's important to understand that there are more than one types of standard deviation, okay? And there's more than one type of average. But I'm going to talk about the standard deviation. If you remember STAT, you know that the standard deviation is what it says it is. It tells you how much things tend to vary or differ, okay, away from the mean, either up above, either higher or lower than the mean, okay? And we have two types of standard deviations. One is for what we call a population, and the other is what we call for a sample, okay? And here we're using so here we're using the arithmetic mean, and in this case we're using a standard deviation for a sample, okay? Why? Well, this is what we would call a sample of convenience. And basically what we've done is we've just gotten the data from these employees. We don't know, and we would be absurd to try to argue that what we see here is representative of all call center employees for all time. So we deal with the sample. Again, this is part of this thing of management science, of making sure that we've got clean data. And so that part of this case is pretty easy. And the next thing we're going to do, once we have the standard deviation and the mean for all of these different people, okay, is we're going to standardize those scores, okay? And now in the standardized tab, and let's talk about it, okay? Over in column A is the employee, all right? Then in column B through column K, we have the metrics. And we're going to standardize these data. We're going to clean them up. And I want you to notice something, all right? And we'll click on the FX and see. Here are the function arguments. This is from the support personnel. You can see that. The support personnel in the exclamation point means the tab B2. That's our X, or our observation. Then we're going to get the mean. Okay, for that. And we're referencing back to the support personnel tab, and then we're going to get the standard deviation. And so we're standardizing those, and we're using that standard function. Now, over on page 343, he explains what it means to standardize data. And this is familiar territory. If you've had stat, should be. Maybe if you had college math or something like that, you should have had stat at this point. We compute a z-score, okay? And a z-score lets us put our observation into perspective. And in this case, it's going to be where z is x minus n over the standard deviation. So we're going to subtract the mean of a column from each observation, each row in that column, and we're going to divide that by the standard deviation for that column, like average tickets, customer rating, etc. Now over there, when you take a look at the support personnel part 1, those notes that I made for you, the author is assuming that these data are what we call normally distributed. In other words, we have a mean, a median, and that about 2/3 of all observations fall between 1 standard deviation above the mean and 1 standard deviation below the mean. Okay? And if you remember stat, they should have taught you that. And so he's assuming, and he's working with the notion that the data are distributed what we would call normally. They're parametric data because they fit the parameters of a normal curve. Let's see who else joined us here today. Glad to see you, Bronson and Tyler. Glad to see you here. Okay. Now, again, you can always go back and see the video once it's posted. So we've created a z-score, and that's how we've standardized these. Okay? And so we've scrubbed the data up. We took each observation, okay, and we'll just run back through it again. We took the mean for a given column, like the mean for average daily tickets. We subtracted it from each observation, the row, okay? And we divided that by the standard deviation. Now, when we divide something, we turn it into a ratio. And I talked about this the other day. Ratios are the purest forms of numbers we have. And we use a standard deviation, especially the standard deviation for a sample. We're really cleaning these numbers up so we can make comparisons. We wash out any distortions. So as I've said before, part of this, working with this, is these types of data are to clean them up and to work with them. So we're walking through that process. As I mentioned before, we're assuming by the author that the scores here on each of these areas, like average tickets, customer rate, et cetera, they fit the Gaussian or the normal, or what we would call the bell curve. Okay? Now, that's a big assumption because, as I mentioned earlier, we're drawing a sample of convenience. All right? The spreadsheeting part of this is a little tricky, but he walks you through it in enough detail that you can get it done. The more difficult part is understanding why you're doing this. And what we're trying to do is create a standardized score that lets me compare one person versus another. Okay? And you'll notice we're doing a z-score. And the z-score always has two components that are the same. Okay? In the numerator, it's the mean or the average. In the denominator, it's the standard deviation. The wild card in all of that is the n. So we're putting in relative terms how far away this person, employee 142619, how far away are they? We've got this other person up here at 144624, that employee. They've got quite a largeable z-score. And you'll recall that in the module for this week, I have a link that lets you take a z-score and find out the probability of obtaining that z-score. Typically, the larger a z-score, the greater the distance that an observation is from the mean. And that means it's further away on that so-called bell curve. So that's what's going on with here. And we'll just go all the way on down here to 402. Okay. So we're standardizing the data so we can compare them. We're cleaning them up. Now we'll go back up here. Notice on these standard scores, we don't compute any kind of mean, median, nothing. Okay, now, and they do that for each of these areas. That's the rating, tardies, etc. And we discussed what those measures implied for a decision maker in terms of that person being a team player, are they involved in self-development and all that stuff, okay? So that's what's going on with the standardized. Now, we're going to go into the distances, and that one becomes a little bit trickier. But if you look at this, we've created a matrix, okay? Remember, in management science, we always look for a model that we can use. And if we can find a mathematical model, all the better, because then we can take it and manipulate it and see if we have some assumptions about different types of conditions, what it would look like. In this case, we're really not doing that. We're just doing purely just descriptive work to see what this all looks like. Now, I want you to notice something, okay? And we have a graph. So when we have each person compare against themselves, they end up with a 0. And you could see that. Now he walks you through creating a creating a function, okay, and you'll see up here the toolbar. And also in my notes, I talk about what's going on there. And let's start with cell number C3. And C3, we have a 0. And in this case, this person is being compared against themselves. Okay? That's how we tie the matrix together, and then we begin to compare versus other folks. Okay? And I'm going to walk you through that. We're going to get the square root of everything inside this sum, okay? And we're going to use the offset, okay? And the offset function is an interesting one because it basically says, and let's look at this, we're going to look at the standardized, we're going to get data right here from the standardized, here we are, we're going to get data from the standardized tab, okay? And then we're going to come into the distances tab, and we're going to start at A3, And then we're going to subtract that offset with the distances C1, which is 0, and we're going to square that. And we'll get a 0. The offset function says, all right, I find a corner or a point, and then I indicate how many columns I'm going to go, how many rows I'm going to go. That's how I create the matrix. It's kind of like the corner for all intents and purposes. And if you notice, we'll look at this. Well, I'll just go across and let's see how they differ. And this gives us a clue. If I scroll over to, if I go over here to D3, I see that it differs from the other, and I'm still looking at A3 with the offset. But here this time I've moved to D1. Then here in this next one, I've moved to E1. But notice that A3 stays the same. This is a little bit like a data table for all intents and purposes. But because we are comparing things against themselves, we have a graph. Okay? If I come over here, same story. Now, this one is a whopper, I know. And that's why if you go in and you take a look at my notes, they're in the distance, in the support center part 1, the notes that I made over on page, what page is that? 5, and I have them numbered there. I show you comparison of 2 employees, 144,624 versus 142,619, and I show you how they end up with the square root of 4.9. And that's the same distance we find here. So I provide you a little printout of some of the proofs of it so you can see for yourself that it's working. And you can see again, and that's all that's going on, and that's what's going on here. Now we've put them in, and we're using Euclidean distance, okay? This is similar to cluster analysis, except this time we're not trying to see how much things cling together or appear together or occur together. We're looking at things that are outside the norm, okay? Now we're going to go over to the rank tab. So now that we have these distances computed between these folks, we're going to go into the rank, and we're going to rank these. Okay? And we'll go back over here, and here we are. And let's talk about this. For example, here's 144,624, and we're going to rank them against each other. Again, we're using a matrix that allows us to do this. And we're going to rank them. Now, we'll click on this. The rank function returns the rank in a list of numbers, okay? And the rank of a number is its size relative to other values in the list. In other words, the position if you were to sort the list. So when we look at rank, we see the number And that's the first piece of the dialogue, the number that you want to rank. Okay. And then we have the order. That's the reference order. This is an array or a list of numbers. And notice we are talking about the distances array. And then we determine order, and we've got some choices. If the order is it's 0, if it's omitted in descending order. If we want a non-zero value, we create an ascending order rank. Duplicate numbers get the same rank. And you could use a correction to handle ties, and he talks about that. So I'm going to walk you through B2. It says equal rank, okay? And it's going to show the result of comparing this ID 144624 to itself. And we get 0, okay? And we have the distances tab, and the number to rank, and that's C3. Okay? In the distances tab. And then the reference array is, again, it's in the distances tab, and that's C3 through OL3. Okay? And then we have a 1, and that means we're going to rank them in ascending order. Okay? And the last thing we're going to do is we're going to take a -1, and that gives us the self-distance, a rank of a 0 rather than a 1. And that's how the matrix start operates. If I go over here to C2, it's the same story. Now, listen, I understand that this is a tall drink of water. It's like drinking out of a fire hydrant. I get that. I could probably take this textbook and use it just for an entire course. But I think it's valuable for you to see that we can handle pretty large data sets with Excel. But the key point is I want to emphasize to you that when we talk in the big text, the Anderson text, about this management science and finding a model, plugging in numbers, etc., that it's not just something that somebody dreamed up to sell textbooks and torture all of you. It works. We're always looking to find a model. That's why we call it management science, because in science, we always try to find a model. We try to find something that describes what we see happening out in the world. Okay? And you'll notice, we'll go back over here, and here we are. And this time, we're going to use the rank function on the distances. That's the tab, E3. And then the array is C3 to OL3. And we want an ascending order. And then we use the -1 to get a rank of 0 if we do a self-check. If when we compare one employee versus that employee's, when we compare an employee's vertical, the vertical part of the vector or the graph versus the rows, columns and rows. Okay, it looks monstrous. It's not as difficult as it seems. However, this guy he put this together. He's awfully smart. He's scary smart, and he put these functions in these to provide them a fantastic tool. And look, if we're going to deal with them, if you're going to deal with employees and you're going to evaluate them, you want to use the best method possible and the most defensible method possible, especially if you think you're going to have to engage in some kind of disciplinary action. And let me tell you what, I've supervised people probably longer than some of your parents have been alive. And I'm going to tell you, when you have a problem with an employee, it's a challenge. And you'd better have good documentation and good data, because in today's world, if you don't, you may find yourself in a rough spot. Same thing if you want to give people bonuses or rewards. It's got to be very, very fair. Well, you can see we just walked this on over. And notice the array and those correctives. Now over in the Support Center Part 1, that PDF I've got there, I give you some of the summary data there. And so we're going to go down to row 402. And we're going to talk about what we've got here. And remember, we're using that Euclidean distance this time to see how far things are apart. And here we come to row 402, and it counts the number of top fives. And notice it's using the count if, which is a conditional statement, which says count if B2 to B401. Okay? And then we say, and then you'll notice we have less than or equal to 5. And then we have the self-ranked distance corrected there, that -1. And then in row 403, we say, okay, how many are in the top 10s in terms of the size of the rank? How many are in the top 20s? So remember we talked about tucky fences early on, interquartile ranges, that type of thing. And we can mimic that by using this type of set of fences. We have the top 5, okay? And then we have the top 10s, and then we have the top 20s, okay? So we're dealing with the rank, and that's the tab there, and that's how we get those figures. Now, cells B402, 403, and 404, they give us the count of the end degree for the employee ID 144624. The end degree is the count of the number of edges going into a node on the graph. So wait a minute, what are you talking about? Okay. A graph has edges, all right? And the end degree tells you how many edges there are for this employee. He talks about it some there in the textbook, and we talked about that when we did cluster analysis. And the lower the end degree, the more of an outlier you are. Now, I have an illustration there for you, and he does the same thing. Okay? joining two nodes is an edge. And I have those, I show you the nodes and the edges, okay, in this matrix. And over on page 350 to 351, he gives us some more guidance and verbiage about that at the 20 graph level. Okay. If you think about the word n degree, okay, that n implies, you know, how close are you to something? And if it's high, that's you're in the order of the, you're into the mode, you're in the node. The lower, you're out. And we're going to see that. That's a tall drink of water. I understand this. But we're using the graph, okay? And he's using that as an n degree for that employee. So we get the number of nodes on a graph. We're starting to find the edges and then start to take it apart and see where the groups are and then who is sitting outside of those groups. Okay? Now, here we come back to something that is more familiar, right? The K distance. And that's the distance from an employee to their neighbor. Now, for example, if K equals 5, that means everyone's distance to their fifth closest neighbor. Right? Remember, we're talking about where they are on the graph. We're talking about where they are in terms of nodes. And if I look at K minus distance, that's the distance of an employee to their kth or Kn neighbor. So if K is 5, I want to know how far everybody is from their fifth client neighbor. You could go K6, you could do whatever. We work with 5. And we're going to put, and we'll come down to the K distance. And notice here, he shows us another function. We're going to sum this. Okay? And let's talk about that. We've got the function, that's the little curly cube. And then we have the if, so we know it's a conditional statement. And the rank, that's the rank being checked. And that means they're going to go back to the rank tab. You could get a little confused with this when you're cell referencing tabs, but always remember, okay, if you see a word with an exclamation point, it means a tab. So if I click on this, okay, you're going to see that I'm looking for the fifth, but if I also went into the rank tab, they would be heated. They would go hot. Okay? Me? Now, the B1 is our criterion, and that's 5. And then we have a 1 that sets the value of 1 in a vector of zeros. And remember, we have a vector. Remember, I talked about those zeros. That's a vector. And then we have a value of 1. And we take that times what's in C3 to OL3 and the distances tab. And we sum it if it meets those conditions. If it meets those conditions, we take that data and we multiply it times the distances, what's in the distances, C3 to OL3 array. And we have a criterion there, and that's the 5. Again, this is some pretty esoteric stuff, and it does take a little time to absorb it. And I can tell you, I go through his book all the time. I'm just fascinated by how talented he is in putting this together. And I have to just think and rethink and think and rethink, okay? So don't feel intimidated by this. This is pretty heady stuff. And this is a homegrown solution. So he's got a lot of things in here he's worked through. But it's an excellent example of how we find outliers. And he walks us through all of that process. So in other words, what we end up doing is we multiply the vector times the distances row for a given employee ID. And they use a gradient conditional format. And you've taken classes with me, you know I talk a lot about visual display of data. And here is just an absolutely brilliant use of it. And let's look, I'm going to click on the conditional formatting. And I'm going to click on manage rules, and that's how I'll find out what he's doing. Okay? And he's using a graded color scale for B4 to B404. So the higher the score, the larger the score, the deeper the red becomes. So he displays that for us so we can see these really have a high distance. Now, in that K distances tab, you can sort those data if you want to. I did, and I took the top 5 highest, and their employees 143, 406. I've got them in this support center part 2. I've got those 5 listed, and we have some ties. And they're in pages 353 through 352 to 353. Foreman talks about that and illustrates the difference between what he calls a global outlier versus a local outlier. Let me stop for a moment and talk about that. Yeah, I know. It feels like, man, I'm drinking out of a fire hose and you just turn it up even higher. What in the world is that? Well, okay. When we talk about a global outlier is one that we know will always be an outlier, no matter what graph we put it into. A local outlier is one that's, think of it like population versus sample. Okay, that's the easiest way to remember it. This is important for you because it's easy. And again, management science is a thought process. It's easy to overgeneralize situations. It truly is. Okay? Very, very easy. Let me give you today as an example. This is a virtual class session. It's scheduled. It's class. And I've had 4 people in here besides myself. So what I could say is about everybody in this class who's enrolled except the 4 of you, the 4 who are here today, would be you're a bunch of lazy people. You don't care. You just want a degree. And I could make that overgeneralization. I could, on the opposite side, I could say, well, the 4 people, students who are here today, they're heroes. They can do no wrong. And the truth is, and you know this is as well as I do, it's a little bit of both. Okay? So most of the time when we're out in the world, we're going to be working with localized kinds of observations, localized kind of situations. Now, the beauty of these models that we use, let's take standard deviation, is I have a standard deviation for a population, and I have a standard deviation for a sample. And when I use the standard deviation for a sample, I know these findings are not, I can't generalize them to everything. Now, there will be those instances in which a pattern will be generalizable, okay? And we'll talk about that for an example just real quickly, the yield curve. And I think I mentioned this Monday in class after Jonathan Wilson was here, Peter Wilson was here, and we talked about what that yield curve means. When the hump is big in the early period of time, that means you've got an inverted yield curve because people have more faith in the future than they do right now. Right now, they want a high level of return because they think it's a very risky environment. So patterns, so seeing patterns in data, okay, seeing patterns can be important, and that's why we use, for example, the conditional format. And as I said, I'm going on, so folks, listen. If you have to bop off to a class or something, that's not going to hurt my feelings because I know I'm going long today because this is complex. Well, here we start to get the reach distance of each of these employees. And he discusses what those are. And in the reach distance tab, the reachability of, say, A to B, it's just their ordinary difference, okay? And here, let's look at one of these. And this is just the ordinary distance. And we'll look, for example, here at row 1. And here we have the transponded values. And we get the maximum distance for B1 using the distances, using cell C3 out of the distances tab, excuse me. And we've got that formula there. So we're trying to see distances between these and ordinary distance. As we move on here, we're going to start comparing, like, for example, employee 144624 will be using the distances tab, not the K distance. And we're going to do this in all of these so we can see the overlaps and when we look, we see that there's no overlap in neighborhoods. We're trying to define the distinct neighborhoods. And we're trying to find out something pretty simple, okay? That is, how tightly knit is the neighborhood, okay? And those who are outliers, how far away are they from the centroid point or center point of a neighborhood? In other words, how much of an outlier is it really? And this is where he gets over into this final tab where we do a ratio, and you'll see it here. And he talks about that over on page 356 and 357. And he uses conditional formatting again, and gradient conditional formatting. And we're using ratios of that employee's average reachability, okay? And the higher this local outlier factor is, the more it's an outlier. And we can sort those values and find them, okay? I'm certain if you're like me, you're sitting there going, whoo, man, I need a sip of water. This has been something. And this is pretty complex. And it's one of these that I wanted to show you this so you could see just a fantastic application of these functions, but more importantly, a really, really outstanding example of how we took the idea of a graph, okay, which is a model, a collection of observations that's centered around a vector, those zeros, when I compare one thing versus the other, okay, and we use Euclidean distance to determine, this time, not clusters, but those who are outliers. Now, as we mentioned before in chapter 1, and I'll finish with this because we have been to the Kentucky Derby and back. We've actually run the Preakness today for all intents and purposes. The problem solving is one thing. Decision making is another. And so when we identify these top outliers, okay, those that have these employees that they have the highest, and we can just basically come over here and look at the outlier factor. This tells us how reachable are they to their nearest neighbor. Here's the local outlier factor, and well, we can put them in ascending order, in descending order, and then we can then we would start with each of those employees, say the 5 largest local outlier factors, and we go back and start to look at their component scores. And we want to find out, okay, who they are. Now I'm going to do this. I'm going to come down here and I'm going to put a filter on this. Well, I'll come all the way down to 402. 401, excuse me. And I'm going to sort and filter. I'm going to use a filter. Okay. And I'm going to rank these from largest to smallest. I'm going to cancel this because I think I think I got a better idea. So I'm going to go back over here to the filter. I'm going to toggle it off. I think what I want to do is sort this array. I think I'll get better results with the sort. So I don't like I'd rather do a sort. So we're going to do this. Come down here. And I'm going to come over to the sort and filter. I'm going to do a custom sort. All right. Now we're cooking. And I'm going to sort by local outlier factor, largest to smallest. Now let's take a look. There we go. We have the highest one. And we have these employees. And if I want to take the top 5, here's 2, 3, 4, 5, and 6. That'll be the top 5. That's going to be the group. That's going to be my highest 5, okay, based on the local outlier factor. Now, when I look at this, I'm a little concerned because I want to make sure I've got the highest out. That's strange because it gives me some of these look quirky. 4, 3, 2, 4. See, the 1.29 is higher, 1.35. So that's strange. So I'm going to go back here to the original. And I'm not happy with what I'm seeing here in terms of the sort. It's giving me some strange, but again, I could go ahead and do I could go and count if it's above a certain level or whatever. But here's the point. Once I identify those employees, then I'm going to go back over here to the support personnel sheet where the raw data are and start to look at their characteristics. And then make an assessment and then make a decision. Well, listen, I thank you so much. I know this is an exceptionally challenging piece of material and some pretty challenging material in the text, as well as taking this and looking at this spreadsheet and disassembling it. And if you want to know that for sure, take a look at my notes, Support Center Personnel Part 1 and then Part 2. And you'll notice I've got about 15 or 16 pages of notes there. So I can try to explain it to you and to remind myself, etc. Well, thank you so much for being here. I appreciate it. And you know the stuff you have to upload for the workshop credit. So we're good to go. Have a great week. Thank you. Let me stop for a moment. Does anybody have a question? Or you're like me, you're ready to run out of here and take a deep breath. Looks like you're ready to run out and get a deep breath. Okay. God bless you and thank you so much.